Hello everyone, now we will discuss on the topic air pollution management, air quality survey, National Ambient Air Quality Index part 2. In this class, we will focus on National Ambient Air Quality Standard and Air Quality Index. In our previous classes, we discussed on the ambient air quality standard, and we have seen for different pollutants different permissible limits are provided in the standards. So, the main objective of air quality standards are to indicate the levels of air quality necessary with an adequate margin of safety to protect the public health, vegetation and property, to assist in establishing priorities for abatement and control of pollutant level, to provide uniform yardstick for assessing air quality at national level, and to indicate the need and extent of monitoring program. Now, we will see the evolution of National Ambient Air Quality Standard in India. So, in 1982, air quality standards was first introduced, and at that time 3 pollutants SO2, NO2 and suspended particulate matter were considered. In 1994, this standard was revised and 7 pollutants were included in this standard, that is SO2, NO2, RSPM, respiratory suspended particulate matter, SPM, suspended particulate matter, lead, ammonia and CO. So, these 4 pollutants are added in 1994, and the concentration of these pollutants are also defined what should be the permissible limit. In 2009, again it was revised, and the air quality standard in 2009 contains 12 pollutants like SO2, NO2, PM10, PM2.5, ozone, lead, ammonia, carbon monoxide, C6H6, BAP, arsenic and nickel. So, these are the different pollutants, 12 pollutants, from 7 to 12 it is increased in 2009. The BAP is benzopyrene, a major indicator of polycyclic aromatic hydrocarbons or PAHs, and during 2019 to 24 review of air quality standards is proposed of 2009 to 2014, and this is planned under NCAP, that is National Clean Air Program. And National Ambient Air Quality Standard, here we see as per 2009 when 12 parameters were included, like say as given here SO2, NO2, particulate matter, PM10 and PM2.5. PM2.5 means as already we have discussed, that is size less than equal to 2.5 micrometer, and ozone, then lead, carbon monoxide, ammonia, benzene and BAP, arsenic and nickel. So, these 12 parameters are included, and we see here time weighted average. So, different pollutants have different impact on human health. So, the concentration is taken different weighted average, time weighted, somewhere it is annual, and we see 24 hours, some 8 hours, like this we have already discussed on this. And as per the national quality standards, the industrial, residential, rural and other areas, as per 2009 air quality standard, industrial, residential, rural and other areas have been made into the same one category, and ecologically sensitive area notified by central government is made into the other category. So, these are the salient feature of this, and in this case we see that 24 hourly or 8 hourly or 1 hourly monitored values as applicable shall be complied with 98% of the time, 2% of the time they may exceed the limits, but not on 2 consecutive days of monitoring, and annual arithmetic mean of minimum 104 measurements in a year at a particular site taken twice a week 24 hourly at uniform intervals. So, these are the process of collection of data on air quality. Now, we will discuss on air quality index. So, we have come to know that there are 12 air quality parameters and it is measured across the year following certain methods or procedure. So, for 12 parameters we will be getting large number of data and their impacts will be different and all are present in the air. So, what will be the cumulative impact? That is the most important point for assessing the quality of the air. So, that is why new approach has come, that one index will be given that will give some indication about the potential of the air to make harm on human health or animal and plants or on the environment or on the society. So, that way air quality index is introduced, just like say CGPA of the performance of any students. So, different subjects have different scores, but CGPA is calculated on the basis of some formula and then one number is assigned. So, that indicates that what performance the candidate is having. So, similar way air quality index is given to identify the quality of the air. So, air quality index is a tool for effective communication of air quality status to people in terms which are easy to understand. It transforms complex air quality data of various pollutants into single number, that index value, nomenclature and color. Computation of AQI, air quality index, is done using real time data of continuous ambient air quality monitoring stations. So, in the previous class we have discussed that continuous standard air quality monitoring stations are there, where continuously data are being collected and recorded. So, those data are used for the production of this air quality index, and the air quality index consider 8 pollutants. So far, although the standards contains 12 pollutants, these here it contains 8 pollutants: PM10, PM2.5, NO2, SO2, CO, O3, NS3 and PB. This is basically for Indian scenario, and it is calculated only if data are available for minimum 3 pollutants, including either PM10 and PM2.5. Any of these two must be included in the air quality index, and the index values have been given in such a way that quality can be defined into different category. So, there are 6 AQI categories, namely good AQI 0 to 50, satisfactory AQI 51 to 100, moderate AQI 101 to 200, poor AQI 201 to 300, very poor AQI 301 to 400 and severe, that is AQI 401 to 500. So, this is the different AQI categories and the quality of the air. This is with respect to Indian context. Now, we will discuss how can we develop the AQI or aggregated AQI, that is collectively what is the impact. So, for that we need to develop sub indices, that is for individual pollutants, and then we will get the aggregate of those. So, and these the sub indices or sub index of any pollutant, that will be related to the concentration of the pollutant. So, there will be some mathematical relationship, and here you see from environmental measurement we get the concentration of different pollutants. So, those pollutant concentration will be transformed into some sub indices corresponding to each pollutants. So, say I1, that is index 1 for pollutant 1. So, I2 for pollutant 2. So, In for pollutant n. So, that is I1 is a function of x1, this is I2 is a function of x2, like is In is a function of xn. So, that way we are getting I1, I2, In. So, these are sub indices, and aggregating this we can get this is the total index or aggregate index, that is function of I, that is the function of I1, I2, I3, In. So, there are two steps basically for the determination of air quality index, step 1 and step 2. In the step 1 we determine the sub indices, and in the step 2 we get the aggregate index. here the weight values of individual air pollutant related parameters, for example, pollutant concentration transform into a single number or set of numbers. The result is a set of rules, set of equations that translate parameter values into a simple form by means of numerical manipulation. Now, we will see the structure of an index. So, the sub index is first developed, and we know that this is a function of the pollutant, and this function may be linear or may be of other types, and then once we will be getting the different sub indices, we will be getting the aggregate of it, that is function of I 1, I 2, I n etcetera. So, that will give us the aggregation of sub indices. Now, as I mentioned that sub indices or sub index may be of linear or non-linear type. So, very common is a linear one, very simple is one a linear one I x relationship, concentration of pollutants and impact relationship. So, I is equal to alpha x plus beta, when alpha is slope of the line and beta is equal to intercept at x equal to 0, because I equal to alpha x plus beta is a linear expression. So, this is one typical relationship which can be used for the calculation of the sub index or sub indices. Another method for the determination of sub indices is mentioned here. The general equation for the sub index I for a given pollutant concentration C p as based on a linear segmented principle is calculated as this: I I is equal to I H I minus I L O divided by B H I minus B L O into C p minus B L O plus I L O, where B H I is the breakpoint concentration greater or equal to given concentration, B L O breakpoint concentration smaller or equal to given concentration, I H I high basically I H I equal to A Q I value corresponding to B H I and I L O equal to A Q I value corresponding to B L O, and C p is the pollutant concentration. Now, we will see how we can identify the B H I, B L O etcetera. Okay. So, one typical example already we have discussed in our previous classes on the impact of CO on human health. Okay. So, this BO and BLO and HI is basically determined on the basis of some relationship and from some study. So, those study that computation of the AQI requires an air pollutant concentration over a specified averaging period obtained from an air monitor or model. Taken together, concentration and time represent the dose of the air pollutant. Health effects corresponding to a given dose are established by epidemiological research, as air pollutants vary in potency and the function used to convert from air pollutant concentration to AQI varies by pollutant. Thus, ambient concentration values of air pollutants and their likely health impacts, known as health breakpoints, are important for the correct response towards the air quality standards. So, here we have got one point, that is breakpoint concentration. So, from this figure it will be very clear what the breakpoint concentration means. So, with respect to carbon monoxide, as already we have discussed earlier, that exposure time, and this is the concentration of carbon monoxide in the blood or in the hemoglobin. So, if we see, and these are the effects. So, you see this is time, this is our concentration. So, if we can take a fixed time, so here we can take a fixed time, if we go up here. So, this point and this point we are getting. Okay. So, this you see here, headache is starting from this point and it is above this, there will be some collapse. Okay. So, this impact on the health is taking place within this limit, this point to this point. So, this is, that will be the BLO and this will be BHI, and this BHI, this how much, 160 ppm, and this equal to 300 ppm. Okay. So, these are showing, this point 160 ppm, for this same time of exposure the minimum concentration, that is 100 ppm, will be giving us some impact that is represented by this band, that is headache etcetera. And when the concentration is more 300 ppm, for the same exposure time we are seeing another symptom, that is your vomit or collapse. Okay. So, now the impact is changing. So, for this particular impact, this is our lower dose or BLO value, that is breakpoint, that is breakpoint concentration, and this is our higher breakpoint concentration for the same symptom on the human health. So, that way we are getting BHI and BLO, and for this we will be having one impact here, that is IHLO for BLO, and IHI we will be getting at this point. So, these two different impacts we are getting in this graph. So, that way the impact which we are getting, those are different, and BHI and BLO we are getting from this type of relationship, and Cp minus BLO. Say one example, this is 100, this is 300, any point say 200 in between. So, in between means this one. So, that is our base point, that impact of ILO plus some increment on the impact because of the increment in the B values, that is Cp minus. So, this is our Cp 200 minus 100. So, due to this increment we will be getting some increment in this impact also. So, that increment, that is equal to IHI minus ILO total because of this change in the B value from BHI to BLO. So, IHI minus ILO divided by BHI minus BLO into this one, that is Cp minus BLO. So, this is our increment, and ILO was the impact related to the lower value of the B or the concentration, that is your BLO value. Okay. So, that way this impact is calculated, and now we will see that breakpoints for CO for different country varies, okay, because this AQI ultimately is developed on the basis of some relationship as you have mentioned, and then individual indices are determined, and then aggregative indices is determined, and these values are different, AQI values are different for different quality of the air. Like for good quality, for Indian context, for CO, that is concentration is 1 mg per meter cube, but for US that is 8 hourly basis, but it is 5 mg per meter cube. So, similarly, it is satisfactory here 2, here 11. Similarly, for NO2 for two different countries India and US, you see here 24 hour basis our data collection, here 1 hour basis US data collection, and they are good, satisfactory, moderate, poor, very poor, severe. India we have this type of classification of the air quality, but US has another type of classifications of the air quality, and their values are also different. So, that way the air quality index are not similar for each country. Individual or sub indices we can determine, and then we will be doing the aggregation of the sub indices, and this can be done by different ways. Once the sub indices are formed, they are combined or aggregated in a simple additive form or weighted additive form, like say I equal to aggregated index sum of Wi I, where Wi sum of Wi is equal to 1, and I sub index for pollutant I, and Wi is the weightage of the pollutant. So, this weightage and weightage can be given by brainstorming involving experts on this area, and say then root some power form, that is nonlinear regression form, that is I is equal to aggregated index, that is equal to sum of I to the power p and whole to the power 1 by p, where p is the positive real number. So, this type of expressions can also be used. Root mean square form has also been proposed, that is I is equal to 1 by k I square plus I 2 square plus dot I k square to the power 0.5, and minimum or maximum operator, that is another approach, that is when we are calculating the individual indices. So, we can consider the maximum value of individual indices as the aggregative index. So, in Indian context this process is implemented. Now, we will see some example of air quality index, that is green index GI. So, green index, this is one of the earliest air pollution indices to appear in literature, and it was proposed by Green 1966, and it included just two pollutants, that is SO2 and COH. COH is coefficient of Hage. So, the SO2 impact of SO2, that is individual impact, is a function of x and linear function. ISO2 equal to 84 into x to the power 0.431 and ICOH equal to 26.6 into x to the power 0.576. So, that is as per green index, and then these are the individual indices, and ISO2 sulfur index, ISO2 sulfur dioxide subindex, ICOH coefficient of Hage subindex and x observed pollutant concentration. Then green index aggregative is determined like this formula 0.5 and the sum of ISO plus ICOH, that is the arithmetic mean of these two. The very simple form was proposed, and here are some examples. By using this, the GI for SO2 and COH index 0 to 25, SO2 this concentration and COH is 0.9. So, 25 to 50, so 0.3 to 3, and then 50 to 100, 1.5 to 10. So, this 1.5 and 10 for these two different pollutants, and they have given different descriptions of this air quality. So, this is 0 to 25 desired, and then 25 to 50 alert, and 50 to 100 extreme. So, this remarks that desired means clean safe air, if it is alert means potentially hazardous, and extreme means curtail air pollution sources that is needed for the preventive measures. As the index did not include any other pollutants besides SO2 and COH, it had limited application. Now, another example is Ontario Air Pollution Index. So, here API is equal to 0.2 into 30.5 into COH plus 126 into SO2 to the power 1.35. So, aggregative API is presented here. There also same way, you see this is the sum, that is the arithmetic mean of these two individual indices, and individual indices are defined by this. Okay. So, that way, so here we can see API is equal to this one. So, this 30.5 into COH can be the first indices, and 126 into SO2 can be the second indices for SO2. So, this the API can be calculated by using this formula. Again it is a function of your I1 and I2. So, that way API was proposed, and both COH and SO2 are 24-hour running average, and the values of index was determined as 0 to 31, that is acceptable, 32 to 49 advisory, 50 to 74 first alert, 75 to 99 second alert, and 100 episode threshold level. So, that way one method was implemented. Another example is most undesirable respirable contaminants index MURC. So, MURC was published in 1968, taken from OAT 1978. MURC is based on this expression, that is MURC is equal to 17 to x to the power 0.7, where x equal to COH units. So, this is based only one parameter, that is COH units, and this equation is obtained such that COH values ranging from 0.3 to 2.15 give MURC values ranging from 30 to 120 approximately. 5 different descriptions are reported for varying ranges of the MURC index shown in table, that is 0 to 30, 31 to 60, 61 to 90, 91 to 120 and 120. So, COH values are given for different indexes, and the descriptions is also given, that is extremely light contamination when it is 0 to 30, 31 to 60 light contamination, 61 to 90 medium contamination. So, 91 to 120 heavy contamination, 120 means extremely heavy contamination. So, these are the classification of it. Another is Oak Ridge Air Quality Index. So, Oak Ridge National Laboratory published the Oak Ridge Air Quality Index in 1971, and it was based on the 24-hour average concentration of SO2, NO2, PM, CO and photochemical oxidants. And the sub index is calculated as the ratio of the observed pollutant concentration to its respective standard, the ratio was there, and as reported by the Babcock and Nagda, the ORAQI aggregation function was a nonlinear function. So, ORAQI that is equal to 5.7 into sum of II to the power 1.37, where II is the individual indices, that is x by xs I, where x is the observed pollutant concentration, xs is the pollutant standard and I is the pollutant. Okay, so, that way it is, and as given here. So, PO, SO2, NO2, CO, PM, these are the standard values and that were used in this expression. And although well defined descriptions are given, its developers imply no correlations with health effects. It is also difficult to explain to public and involves complex calculations. Now, we will see the Indian Air Quality Index. So, for the development of Indian Air Quality Index, the first step is to calculate the sub indices or the index for individual pollutant, that is based on this linear segmented principle just we have discussed, and that is IP equal to I HI minus ILO by BHI minus BLO into Cp minus BLO plus ILO. But here one thing, here ILO AQI value corresponding to BLO, we need to subtract 1 from ILO if LO is greater than 50. Okay. Then finally, AQI will be the maximum of IP. So, this is the methods for the calculation of Indian AQI, and here we see the breakpoint concentration for different pollutants, 8 pollutants as mentioned here, and then category AQI category, that is good, satisfactory, moderately polluted, poor, very poor and severe. So, this is for different the concentration of different pollutants. Okay. So, we have to get the index and then sub index, and then what will be the maximum value of that sub indices, that will be the AQI for Indian context. So, here some values are given, that is for breakpoint values are given. So, for this say for example, so BLO for this case is for PM10 is 0 and 50, when the AQI range will be 0 to 50. Similarly, say for 51 to 100, if it is, then the this is the satisfactory I HI on this one. So, this I HI will be 51 minus 1, that will be 50. Okay, so, that way we can calculate, and the different quality of air, that is good, satisfactory, moderately polluted, poor, very poor and severe, that is different health impact which are associated with this. A minimal impact, that is good, satisfactory, may cause minor breathing discomfort to sensitive people, and moderately polluted means may cause breathing discomfort to people with lung disease such as asthma, and discomfort people with heart disease, children and other adults. And then poor may cause breathing discomfort to people on prolonged exposure and discomfort to people with heart disease, and very poor may cause respiratory illness to the people on prolonged exposure. Effect may be more pronounced in people with lung and heart diseases. Severe may cause respiratory effects even on healthy people and serious health impact on people with lung, heart diseases. The health impacts may be experienced even during light physical activity. So, these are the severe condition. So, we will be discussing in tutorial how to calculate the AQI with some example. Now, we will see that for the determination, quick determination of AQI, already some Excel sheets are developed and available in the CPCB website. So, a user friendly evaluation of AQI has been developed the user needs to input at least 3 values of pollutant concentrations, including at least one of the PM10 or PM2.5 in the blue cells, and the sub indices are calculated, thus displaying the final AQI along with the color signifying the AQI category. The health impacts corresponding to the AQI category are detailed in the legend at the bottom of the sheet. So, this Excel program can be obtained from the CPCB. So, this is one example of it. You see here we will be putting the values here, concentration values. So, sub indices will be generated and ultimately AQI will also be given here. So, here 97 means it is less than 100. So, satisfactory. So, this color is also showing satisfactory. Okay. So, this is developed by IIT Kanpur, and this can be used for the calculation of air quality index, but we need at least 3 air quality parameters, out of which one must be either PM10 or PM2.5. And now, we will see the air quality index of Delhi from year 2016 to 2009. So, you see here 2019, 18, 17, 16. So, we have 0 in 2016 and 2018, that is good quality index was 0, and here in 2019 2 and 2017 2, and then days in various air quality index. These are days out of 365 days, 2 days were good in 2019 and 2017 2 days, but 18 and 19 there is not a single day was good, and then satisfactory, that is 59 days, 53 days, 45 days, 25 days, and moderate, that is say 121 and 106, 125, 105 and 83, and here poor 103, 113, 115, 120. So, that way, and very poor you see 56, 73, 89, 101, and then severe 24, 29, 25. So, what we can see here, since 2016 at least 50% of the air, the air quality is not good and it is poor and very poor category. This slide shows us the air qualities index values of few cities of India for the year 2019. So, here different cities are given. So, out of 365 days, how many days different air quality are shown. So, it is very clear that with respect to Delhi, the more number of days in these places the air quality index is good. So, air quality is better. So, that air quality index help us to get some idea about the quality of the air by a single number, and it is very important for assessing the quality of the air. So, up to this in this class, thank you very much for your patience.